Hi everyone, in today's class we are going to discuss the general constraints in design of medical instrumentation. So when we are talking about the medical device, this is something we are used for making or analyzing the measurements of physiological parameters from human body, right? So this is not like a normal electronic device. This is the device here we are going to deal everything related to our body physiological parameters. Okay, so when we are dealing these type of physiological signals, we have to consider so many factors and we have to think so many aspects. Okay, if you say measurement range of that particular physiologic signals, it is like a very low when compared to other non-medical parameters. Mostly it will found in microvolt range. And if you take the frequency range of the some biomedical signals, it also again in found in audio frequency range or below. So again we need certain components to process this image so that it can be taken into the next level. So these are things it's found as there are some few limitation. Okay, we have to be it could be found as some challenges when we are dealing with this type of physiological signals. So what are the additional challenges or the constraints when we are dealing or developing with any biomedical devices, in the sense inaccessibility of signal source, variability of physiological parameters, interference among physiological system, transducer interference problem, higher possibility of artifacts, safe level of applied energy, patient safety consideration, reliability aspects, human factor consideration, and government regulation. Okay, so let's see each one by one. Okay, if you take inaccessibility of signal source, in the sense since all the biological signal or biomedical signal, everything we are getting from our body, right? So the accessibility of these biological signals, again it's very big question mark. The thing is that if you want to record a EEG signal, okay, that is the brain activity, we need either, that is a two option. We have to either go with non-invasive type or invasive type. So if it is invasive type, then we have to use needle electrode to make a direct contact with biological signal. That means direct contact with your brain, so that you will have electrical activity of the brain. Or if you are going for a non-invasive type, then you will go with the surface electrode. Just you will place over the skull, and then you will capture the electrical activity of the brain. Okay, so the thing is, if you are going with the surface electrode, the accessibility of the signal is very low. The detailed information of the signal is again very low when compared to the invasive type. So these are the things. But if you see the invasive type, if you are, most of the people will not feel more comfortable in to go with the invasive type, since we need to operate. We have to open the skull, then you have to use place the electrode direct contact with brain, or you have to use the needle electrode to make direct contact. So it's kind of like a patient will not feel comfortable with this type. So if you have, since if you have two types of, two different option, the again the accessibility of the signal source matters a lot. One have some advantage, another have some advantages, like. So this is going to be the constraint, because the accessibility of signal source, the first and foremost, is very important. But the thing is here, since all our biological signals are it's been taken our body, the accessibility of signal source found to be a major constraint when we are developing medical device. Second one, if you are taking variability of physiological parameters, again if you are focusing on one parameters, it has influence with other parameters. If you are measuring electrical activity of the heart, in some way it will have influence with other activity like brain activity or other organs activity. Okay, since our body is so much complex, biological complex system, it has the influence of other activity also when you are looking for one specific activities. That is the variability of physiological parameters. That is considered as the other constraints. Third one is interference among the physiological system. Okay, so the variability of the physiological parameters, in other way also you can say, these physiological signal is not a static one, it is a dynamic one. It will keep on changing from time to time. Okay, if you take heart rate, it will if you measure the heart rate at morning, for example, it is a 72 beats per minute. If you take it afternoon, it will not have same heart rate. It will vary from person to person. And also it has it's been influenced by so many factors like gene, that obesity and everything, and other biological factors also. Okay, so if you are measuring, if you want to measure such a dynamic physiological signal, it's not a, very easy task when compared to the other non medical parameters, right? So that could be the major constraints if you are measuring the physiological signal. And third one is the interference among the physiological system. As I said before, if you are looking for any specific physiological system in any way or some way, it will interfere with some other physiological system. So the influence of other activity or other interference will be there for while measuring the physiological specific physiological function. Okay, so in that case we have to very keen what we want to measure and how we are measuring it. Okay, so that could be the other constraint. And third one is the transducer interference problem. Okay, so transducer interference problem is that because if you take any medical device, if you want to pick up any biological signal from our body, the main component, the hard component, will be used in any to pick in any to pick the biological signal is nothing but is a transducer, right? So when we are choosing that any type of transducer while placing on our body or the skin where you want to measure any type of signal, the placement of transducer against matters a lot, and the load of the transducer against matters a lot. The thing is that when you are having loading capacity, okay, loading effect of this transducer should no way affect the biological signal what we are looking for. Okay, so so this thing we have to be taken into account while designing the transducer, while choosing the transducer, because the loading effect of transducer will interfere the biological signal what we have to capture or what we are looking. So that is the one other constraints, if you it would be considered as one of the major thing when we are designing the biomedical signal, biomedical device. So next one is the higher possibility of artifacts. Yes, the higher possibility of artifacts, the reason is that here we are measuring the physiological signals or recording the physiological signal from the alive patient. Okay, in a living being. So in that case, that people have the tendency to move, all right, while taking measurement or while recording any data with the help of medical device. So that tendency of people will tend have some movement. That movement will produce some artifacts, will interrupt the recording of data. So that could be the major challenges in designing medical device that we have to encountered in different ways, like choosing a proper transducer, and you have to use a transducer with a strong adherence capacity, so that even the patient will move, it will not affect the transducer, so that the data will also will not be affected. Okay, so and also so many things like algorithm point of view, we have to strengthen in order to remove certain artifacts to have a real valuable data. Okay, so these are the possible things we can encounter the some artifacts. Okay, so next additional constraints what we will challenge or face when we are designing a medical device, that we will be discussed in next class. Thank you.